11.1 Basic Concepts. If you go to a supermarket and you select 5 pounds of peaches at $2.49 a pound, you're going to know that before you get to the counter, you're going to be charged $12.45. This is an example of deterministic phenomenon. What that means is it can be predicted exactly on the basis that you have the information beforehand. You're able to obtain the information and you're able to predict it exactly. On the other hand, if you're the manager of the supermarket, you have to place orders for the peaches every day, but you don't know how many pounds the customers are going to buy per day. And this is an example of random phenomenon, which can't be predicted exactly. And even though we can't be certain whether a given result will occur, like customers buying a particular amount of pounds of peaches, we can often obtain a good measure of its likelihood, which is going to be the probability. And we're going to discuss various different ways of finding and using probabilities. Before we get into that, we got to learn some other terms. So any observation or measurement of a random phenomenon is going to be called an experiment. And the possible results of the experiments are called results. And the possible results of the experiments are going to be called the outcomes. And the set of all possible outcomes is going to be called the sample space. And any such subset of the sample space in which any such subset of a sample space is called the event. And these are going to be all the favorable outcomes of These are going to be all the favorable outcomes. And the probability of an event can be measured in two ways. The first way is going to be theoretical, which is basically mathematically, where we use formulas to best predict the likelihood or the probability of an event happening. And the other way is empirically, by doing it through experiments. So let's do an example. If a single coin is tossed, find the probability that it will land heads up. So how would we do this? The experiment here is tossing a single fair coin. In the sample space, as we know, the possible outcomes are either going to be heads or tails. And the event whose probability we seek is heads. And since one of the two equally likely outcomes is a head, the probability of a heads is the quotient of 1 and 2. So the probability of heads is simply 1 over 2. And it's going to be written as probability of heads equals 1 over 2, or probability of the event is 1 over 2. So let's look at the theoretical probability formula. If all outcomes in a sample space are equally likely, and E is an event within that sample space, then the theoretical probability of event E is given by the following formula. The probability of the event is equal to the number of favorable outcomes over the total number of outcomes. Which is N of E over N of S. And say we're going to do the experiment empirically. What that means is actually doing the experiment. So say if you wanted to see how many times a cup landed on its top or bottom, instead of doing a theoretical probability formula, we can do an empirical probability formula, which is actually doing the experiment itself. In that case, the formula is as follows. So the probability of the event happening is going to be the number of times event E occurred over the number of times the experiment was performed. So let's do another example. Finding the probability of having daughters. So Kathy wants to have exactly 2 daughters. So Kathy wants to have exactly 2 daughters. Assuming that boy and girl babies are equally likely, find her probability of success for the following cases. She has a total of 2 children. And the other case that we want to find the probability of is she has a total of 3 children. Let's work on A first. Let's solve A using the tree diagram, just to give you a picture. So the first child is going to be either a girl or a boy. The second child can either be a girl or a boy. And our possible outcomes are going to be girl, 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 boy, boy, girl, or boy, boy. So there are going to be 4 outcomes with one event that is favorable. And what do we know from our theoretical probability formula? It's going to be as follows. So the probability of the event is going to be 1 over 4. Because remember, there's 4 total cases and only one outcome that we're looking for. So the probability of Kathy having a total of 2 children that are girls is going to be 1 over 4. Now, what about B? Let's do a tree diagram again. So the first child can either be a boy or a girl. Second child can either be girl and a boy, girl and a boy. And the third child can either be a girl and a boy, girl and a boy, girl and a boy, girl and a boy. And let's look at the outcomes of all these events. Girl, girl, girl. Girl, girl, boy. Girl, boy, girl. Girl, boy, boy. Boy, girl, girl. Boy, girl, boy. Boy, boy, girl. And boy, boy, boy. And what were the outcomes that we were looking for? Kathy wants to have exactly 2 daughters. So this is not a favorable outcome. This is a favorable outcome. Favorable, not favorable, favorable, not favorable, not favorable, not favorable. And we have a total of 1, 2, 3, 4, 5, 6, 7, 8 cases and 3 favorable outcomes. So it's going to be 3 over 8. So her probability for this case is going to be 3 over 8. Another example. So according to the United States Census, there are an estimated 154.5 million males and 159.4 million females. If a person were selected randomly from the population in that last year, what is the probability that the person would be a male? And in this case, we calculate the empirical probability from the given experimental data. So the probability of being a male is going to be 154.5 million males over the total number of people, which in this case is going to be 154.5 plus 159.4, which is going to be equal to 0.492. So that is a probability. If we picked out a person from the total population, that is a probability that they're going to be a male. Now let's look at the law of large numbers. So whenever we're doing an experiment, the number can be defined as a theoretical probability of that Now let's move on to the law of large numbers. What the law of large numbers states is that as an experiment is repeated more and more times, the proportion of outcomes favorable to any particular event will tend to come closer and closer to the theoretical probability of that event. Now we can look at odds. Where probabilities compares the number of favorable outcomes to the total number of outcomes, odds compare the number of favorable outcomes to the number of unfavorable outcomes. Odds are commonly quoted rather than probabilities in horse racing, lotteries, and most other gambling situations. And the odds quoted normally are odds against rather than odds in favor. So if all outcomes in a sample space are equally likely, A of them are favorable to the event E, and the remaining B outcomes are unfavorable to the event E. So odds in favor is going to be A to B. Now these are favorable and these are the remaining outcomes. And the odds against would be B to A. Let's do an example. Finding the odds of getting an intern position. So Teresa has been promised one of 6 jobs, 3 of which would be intern positions at the state capitol. If she has equal chances for all 6 jobs, find the odds in favor of getting one of the intern positions. So she has 6 total jobs, 6 total, and 3 of them are favorable, since we want to get an intern position. So we have 3 that are favorable, 6 total. That means we're going to have 3 remaining from our total. So A is going to be 3 in this case. And remember, B is going to be the remaining outcomes. So B is equal to 3. So the odds of becoming an intern at the Capitol are 3 to 3, which is basically even odds. So another example. Finding the odds of winning a raffle. Bob has purchased 12 tickets for an office raffle. So Bob has purchased 12 tickets. In this raffle, the winner will receive an iPad. If 104 tickets were sold all together and each iPad has an equal chance of winning, what are the odds against Bob winning the iPad? So we have 104 tickets total sold. So if we're looking at odds in favor of Bob, we would do, this would be A, and this would be B, but we have to subtract 12 from it. So B would be equal to 104 minus 12, which is going to be 92. So the odds in favor of Bob would be 9 to 92. 12 to 92. But we're looking at the odds against Bob. And that's very simple. We just switch it from A to B to A. So Bob has the odds of 92 to 12 against him from winning the raffle. Now let's look at converting between probability and odds. Let E be an event. The probability of E is going to be equal to A over B. Then the odds in favor of E are A to B minus A. If the odds in favor of E are A to B, then the probability is going to be A over A plus B. And if you guys are a little confused about that, when you break it down even further, if we're talking about what I did right here, is we know that in the theoretical probability formula, B was going to be the total amount of outcomes. and A is the favorable outcomes. But when it comes to finding the odds of something, and we're doing A to B, or odds of X to Y, it's going to be the number of favorable outcomes to the number of total outcomes minus the favorable ones. So if you're getting confused from earlier when we talked about odds and we move on to this, just remember that when we're converting between probability and odds, that the probability for B is the total number of outcomes, and then when we switch it to odds, we have to turn it into the total number of outcomes minus the favorable outcomes for the remaining ones. So let's do a couple of examples. There is a 30% chance of rain tomorrow. Give this information in terms of odds. So we have a 30% chance of rain tomorrow. What does that mean in terms of probability? So probability of rain is going to be 0.30, which is also 30 over 100, which is simplified to 3 over 10. Now, when we're trying to find the odds of it, remember this is total outcomes. This is going to be favorable. And so we have our A, which is 3. Now, to get the odds of it, we have to subtract B minus A. In this case, it's going to be 3 to 10 minus 3. So the odds of rain is going to be 3 to 7. If we're looking at the odds against rain, we just switch it to 7 to 3. Now let's convert from odds to probability. In a certain sweepstake, your odds of winning are 1 to 99,999. What is the probability that you will win? Well, what do we know about probability? It's going to be A over B. And what do we know about this? This is going to be A to B minus A. So how do we convert from odds to probability? Well, we know that if we want to get the total number of outcomes, since this is remaining, to get total, it has to be A plus B. Because this is the figure that we get from here. And A is already the number of favorable outcomes, so it's going to be A over A plus B. And in this case, it's going to be 1 over 1 plus 99,999, which is 1 over 100,000. So that is going to be our probability. So hopefully that makes sense for you guys.